All right, let's break it down slowly and in the simplest way so each part makes complete sense. We'll start with understanding why weather and climate vary in different places, and then we'll go into why we classify things in geography. Part 1. Why does every place on Earth have a unique climate? Imagine you have a big planet, Earth, with different places on it. Every place on Earth has its own climate, which is like its own personality of weather over a long time. 1. Why is climate different everywhere? Think about how the weather in your city might be very different from a place far away. For example, if you live in a hot, sunny area, you know it will be different from somewhere with snow-covered mountains. These differences come from a lot of factors working together. 2. What are these factors? Factors that shape climate include sunlight. Some places get more sunlight than others, like areas near the equator, which are warm, while the north and south poles are much colder. Seasons. Different times of the year bring different weather patterns. For example, summers are hot and winters are cold in many places. Wind and rain. These move around heat and water, changing how warm or cool and wet or dry a place can be. Landforms. Mountains, oceans, and valleys all affect the weather in a place. Mountains might block rain, making one side dry and the other rainy.
Number 3.
Each place is unique. Since all these factors interact in so many ways, every spot on Earth has a unique mix of weather over time, its climate. No two places are exactly the same. For example, the desert is dry and hot, while a rainforest is wet and warm. Even if two places are at the same latitude, one might be rainy, while the other is dry because of how these factors work together. 4. Why don't we describe each place's climate? There are just too many places with too many different types of climates, so describing every single place would be impossible. Instead, we look for general patterns or similarities and use these to help us understand the big picture of Earth's climate. Part 2. Why do we need to classify, organize climates? Now, let's talk about classification, or how we sort and group information to make it easier to understand. 1. Why do geographers classify things? Geographers study places, and there are a lot of places on Earth. To make sense of all this information, they put similar things together into groups. Think of it like organizing a closet. You might put all your shirts together, pants together, and shoes in one place. That way, when you need something, it's easy to find. Classifying climates is like putting things in an organized closet. It helps geographers understand patterns. What does classification do? When we classify, we're making groups. Everything in each group has certain things in common, which makes it different from things in other groups. For example, geographers might group all dry places together, or wet places together, and all cold places together. This makes it simpler to study each group, rather than studying every place one by one. 3. Example of classification. Imagine we have fruits, apples, bananas, and oranges. If we classify them, we could put apples together, bananas together, and oranges together. This makes it easy to talk about each type without mixing them up. In climate classification, we do something similar. We group places with similar climates, like deserts or rainforests, so that we can study them more easily. 4. Why is classification helpful? By putting similar places together, geographers can make maps, charts, and models. This helps them and everyone else understand how different parts of Earth work without getting lost in too many details. Putting it all together. In simple terms, Earth has many different climates because different factors like sunlight, seasons, wind, rain, and land shape them in unique ways. Geographers use classification to group similar climates. This makes it easier to study, understand, and explain the world's climates. By grouping climates, we create order from a complex world, making it simpler to understand Earth's vast range of weather patterns without being overwhelmed by too many details. I hope this clears everything up and makes the concept as easy as possible to understand. Let me know if you want to dive deeper into any specific example. All right, let's break this down into simple, easy steps, so it's as clear as possible. We'll talk about what climatic classification is, why it's useful, and how it helps geographers and scientists understand our world. I'll go step by step with examples to make each idea clear. Part 1. What is climatic classification? 1. What does climatic classification mean? Climatic classification is just a way to organize and group climates. Think of it as a big list where we sort different types of weather patterns so we can understand them better. It's like putting similar things in groups so they're easier to study. 2. Why do we need it? Earth has many kinds of climates, like deserts, forests, and icy regions, and each has its own special weather patterns. By grouping these climates, we can better understand the types of weather each place has, where it's found, and how it affects things around it. 3. How does it help? When we classify climates, we can see how climates are similar or different, understand how climate affects other things like plants, animals, and soil, predict the climate of a place by looking at things like its plants and animals. Example, imagine sorting books by genre, like mystery, fantasy, and science fiction. By grouping similar books together, it's easier to understand what each genre is like. Climatic classification does the same thing for climates. It groups similar climates, so it's easier to study and predict what they're like. Part 2. Why is climatic classification useful for geographers and scientists? 1. Why is it helpful to geographers? Geographers study Earth's land and how it affects people, plants, animals, and weather. When they classify climates, they can see patterns. This helps them predict what a place is like based on its climate. 2. Why is it helpful for other scientists? Soil scientists. Soil depends on climate, so they know a place's climate. They can predict what kind of soil is there. Botanists. Plant scientists. Climate affects what plants can grow in a region. For example, cacti grow in deserts, while big trees grow in rainforests. Zoologists. Animal scientists. Animals adapt to the climate. For instance, polar bears live in icy places, while camels live in deserts. Example, if a geographer sees lots of palm trees and sandy soil, they might guess that the climate is warm and tropical, like in Florida or Hawaii. By classifying climates, scientists can also predict what plants, animals, and soil might be in a place based on the climate type. Part 3. What is a climatic region and climatic type? 1. Climatic region. A climatic region is a big area on Earth that has similar weather patterns because of a mix of factors like sunlight, wind, and rainfall. For example, a tropical rainforest is a climatic region where it's warm and rains a lot, so there's thick green plant life. Another example is the desert, a region where it's very dry, hot in the day, and often cold at night. Climatic regions are large, so one region can cover many areas. This means that one part of a rainforest might look different from another, but overall, they have similar weather. 2. Climatic type. A climatic type is just a kind of climate within a region. It's like saying desert climate or rainforest climate. Each type has its own weather patterns, like how much it rains, how hot or cold it is, and how windy it can be. Example, think of climates like flavors of ice cream. Each flavor is different, like chocolate, vanilla, or strawberry. A desert is one flavor of climate, while a rainforest is another. Each one has its unique taste or set of weather patterns. Putting it all together, climatic classification is a way of grouping similar climates so we can understand and predict them. Geographers and scientists use this system to see how climate affects plants, animals, soil, and land. A climatic region is a big area with similar weather like deserts or rainforests. A climatic type is a specific kind of climate within a region, like tropical rainforest or dry desert. By classifying climates, we can make sense of Earth's many different environments and understand how each one works. This organization helps us see the big picture of Earth's climates, making it easier to study, protect, and live in each unique place. I hope this explanation makes everything clear and simple. Let me know if you'd like examples of specific climates. All right, let's dive in deeper and explain each point in a simple, clear way, just like we're starting from scratch. I'll go step by step. Part 1, 5 main objectives of an ideal climate classification system. A climate classification system has 5 main goals. Let's break down each goal. 1. Tell apart different types of climate. Differentiate all major climates. Imagine Earth has many types of climates. Some places are very hot and dry, like deserts. Others are cool and rainy, like forests. The first goal of a climate system is to help us see how each type of climate is different. Example, think of colors. Red is different from blue, and blue is different from green. In the same way, a desert climate is very different from a forest climate. 2. Show how these climates are connected. Show relationships between climates. Even though climates are different, some of them share similar features. This goal is about helping us understand how these climates are connected. Example, think about a rainforest and a savanna. Both are hot and close to the equator, so they're similar in some ways, but one is wet, rainforest, and the other is drier, savanna. This system should help us see connections like this. Work everywhere on Earth. Apply to the whole world. The system should be usable for any location on Earth, whether it's cold, hot, dry, or wet. This means no matter where you are in the world, this system should help you study the climate in your area. Example, think of a language that everyone can understand. A good climate classification system should work for all areas, like a common language for studying weather. 4. Let us divide big climates into smaller groups, provide a framework for further subdivision. Sometimes we need to go beyond the big picture and study smaller details in each climate. This system should make it easy for us to split big climate types into smaller, more specific ones. Example, imagine you're organizing books. You might start with big categories like fiction and non-fiction, but then you can split them further into mystery, adventure, etc. A climate classification system should let us do the same with climate types. 5. Help us understand why each climate exists. Show causes of each climate. This system should also explain why each climate is the way it is. For example, why is a desert so dry? Why is a rainforest so wet? Example, think about baking a cake. To understand why a cake is fluffy, you need to know the ingredients and how they work together. In the same way, a good climate system should show us the ingredients that create each climate. Part 2. 2 main types of climate classification. Now that we know what a climate classification system should do, let's look at the 2 types of classification: empirical classification and genetic classification. One, empirical classification, based on what we observe. What it means. Empirical means using data or observations, things we can see, measure, or collect. So empirical classification uses things we can observe, like temperature, rain, wind, and humidity, to organize climates. Why it's reliable. Since empirical classification uses facts, data we can actually measure, it doesn't need to change much over time. For example, we know deserts have low rainfall because we've measured it, and that doesn't change often. Example, imagine you have a collection of shells. You sort them by size and color because you can see and measure these things. This is like empirical classification. You're using what you can observe to organize things. Hack 2. Genetic classification, based on the causes of climate. What it means. Genetic relates to the origin or cause of something. So genetic classification is about understanding what causes a climate to be the way it is. It organizes climates based on their origin or cause. Why it can change. Our understanding of climate causes can change as we learn more about the world. So, genetic classification may need updates as science advances. Example, think of sorting shells by where they came from, beach, river, or lake. As you learn more about each place, you might change how you classify the shells. Similarly, genetic classification might change as we learn more about what affects climate. Summary. Empirical classification is based on what we can observe, like temperature and rainfall, so it's stable and doesn't need much change. Genetic classification is based on why or how climate patterns happen, which can change as our knowledge improves. Together, these classifications help us make sense of all the different climates on Earth. The system is like a toolbox that helps scientists, geographers, and anyone studying weather understand, predict, and organize the complex climate patterns around us. All right, let's go even deeper into Köppen's climate classification and explain each part as simply as possible. Who was Köppen? Vladimir Köppen was a scientist from Germany. He studied both plants and weather, and he noticed that certain plants only grow in certain types of climates: warm, cold, rainy, dry. Why did Köppen create this system? 1. Köppen wanted a simple way to group the world's climates. 2. He knew plants are like clues about a place's climate. For example, cacti grow in dry deserts and big leafy trees grow in rainforests. 3. Using temperature and rainfall, he created different climate groups to show how climates vary worldwide. How did Köppen create his climate groups? He used two main things: temperature, how hot or cold a place gets in the hottest and coldest months; rainfall, how much rain or snow a place gets in the wettest and driest months. He used numbers for temperature and rainfall to set boundaries between different climates. For example, if a place is always above a certain temperature and has lots of rain, it might be in a tropical group. If a place is very dry with little rain, it could be in a desert group. Köppen's 5 main climate groups. Köppen divided the world into 5 big climate groups, each controlled by temperature and moisture, rain or snow. 1. Tropical. A. Always hot and has a lot of rain. Think of places near the equator, the middle of the earth. Example, Amazon rainforest in South America. 2. Dry. B. Very little rain or snow, can be hot or cold. Think of deserts where it's mostly dry and sandy. Example, Sahara Desert in Africa. 3. Temperate. C. Mild with warm summers and cool winters. Rainfall is spread throughout the year. Example, Southern Europe or parts of California. 4. Continental. D. Cold winters, warm or hot summers. Found far from the sea, like in the middle of large continents. Example, Canada and parts of Russia. 5. Polar. E. Very cold all year, very little rain or snow, found near the North and South poles. Example, Antarctica and the Arctic. How does Köppen's system help us? 1. Helps us understand Earth's climate zones. It shows where tropical rainforests, deserts, snowy areas and temperate regions are. 2. Helps scientists and geographers. By knowing a place's climate, they can predict what plants and animals live there. 3. Shows relationships. Köppen's system helps us see how climates are connected around the world. Why is Köppen's system still used? It's based on actual measurements, numbers for temperature and rainfall, making it reliable. It's easy to understand. We can quickly tell what the climate is like in different places. It helps with predictions. Knowing the climate helps us guess what plants, animals, and even human activities might be suited to that area. Example summary with Köppen's system. Let's imagine we're looking at 2 places. 1. Place A is hot all year and gets a lot of rain. It would be a tropical A climate, like a rainforest. 2. Place B is dry with almost no rain, but it's hot during the day and cold at night. This would be a dry B climate, like a desert. By using Köppen's climate classification, we can tell what to expect in these places, like plants, animals, and even people's lifestyles. Final thoughts. Köppen's classification organizes Earth's climate by temperature and rainfall, making it easy to understand why some places are wet and hot, like rainforests, while others are cold and dry, like polar areas. It's a helpful map that connects climate to the world around us, showing us how different climates shape the Earth's plants, animals, and even people. All right, let's dive into what megatherms are in the simplest way possible. What are megatherms? Megatherms are a group of plants. These plants need warm weather all year. They can't handle cold. They also need lots of water to survive. Where do megatherms live? They live in places that are always warm and get plenty of rain. There is no real winter in these places. It's too cold. The coldest month is still warm, above 18, which is about 64 degrees Celsius. What kind of rain do these places get? Megatherm areas have at least 1 month with heavy rain. Some areas get 2 rainy seasons in a year. This means it rains a lot in 2 parts of the year, keeping the plants well watered. What do megatherm places look like? The main type of plants here make up tropical rainforests. Tropical rainforests are full of tall, leafy trees that stay green all year. These trees don't lose their leaves because there's always enough warmth and water. Example of a megatherm area. The Amazon rainforest in South America is a perfect example. It's hot all year. It rains a lot, which keeps the forest lush and green. There's no winter, so the plants grow all year long. Why are megatherm plants special? These plants are adapted to constant warmth and plenty of rain. They need these exact conditions to grow well. If they were in a colder or drier place, they wouldn't survive. Quick summary. Megatherms are plants that need hot, rainy conditions all year, grow in places like tropical rainforests, thrive only in areas with no winter and plenty of water. This group helps scientists understand how different climates support different types of plant life. Tropical rainforests filled with megatherm plants are one of the richest and most diverse environments on Earth. Let's look at the next two types of plants, xerophytes and mesotherms, in a very simple way. B. Xerophytes. 1. What are xerophytes? Xerophytes are plants that like dry, hot places. They can survive with little water. 2. Where do xerophytes live? They live in deserts and semi-arid, almost desert areas. Some are found in hot deserts like the Sahara. Others grow in drier, warm parts of places that aren't deserts, semi-arid regions. 3. How do they survive? Xerophytes are built to store water or survive with very little of it. Many have thick leaves or spines, like cactus plants, to hold in water. They are made for high heat, but can get through the cooler, dry seasons too. 4. Example of xerophytes, cacti. These plants store water in their thick stems. Desert shrubs. They have deep roots to find underground water. 5. What's special about xerophytes? Xerophytes are adapted to survive with little water. They thrive in dry, hot climates where most other plants cannot grow. C. Mesotherms. 1. What are mesotherms? Mesotherms are plants that like moderate, not too hot, not too cold weather. They need a moderate amount of water, not too dry and not too wet. 2. Where do mesotherms live? They grow in areas that have cooler winters and warmer summers, found between 22 degrees and 45 degrees north and south of the equator, common in regions like southern USA, parts of Europe and East Asia. 3. What conditions do mesotherms need? They need temperatures below 18 degrees in winter, not freezing but cool. The warmest month should be below 22 degrees, not too hot. 4. Types of mesotherm vegetation. Some mesotherms don't like the cold in winter. Others don't like it too dry in warm seasons. This can include deciduous trees, trees that lose their leaves in winter, and shrubs. Example of mesotherms. Oak trees and maple trees are examples of mesotherms. They grow in places with moderate climates where it's not too dry, not too, and temperatures are moderate. Other 6. What's special about mesotherms? Mesotherms need a balanced climate, not too extreme. They are adapted to places that have mild seasons with no big changes in temperature or rainfall. Summary. Xerophytes love hot, dry places. Found in deserts, cacti are a great example. Mesotherms like mild weather with balanced moisture, found in places with moderate climates. Oak trees and maple trees are examples. Each type of plant is adapted to fit exactly the environment it needs to survive best. This helps scientists understand how different climates support different plants, which shapes the environment in each region. All right, let's break down microtherms and hestotherms even further. I'll explain each part as simply as possible. D. Microtherms. Plants that like cool weather with short summers. 1. What are microtherms? Microtherms are plants that grow best in cool or cold climates. They don't need warm weather to thrive. They are adapted to places where summers are short and mild and winters are long and cold. 2. What temperatures do microtherms need? In the warmest month, the temperature stays between 10 degrees Celsius and 22 degrees Celsius. This is cool, not hot. In the coldest month, the temperature is below 6 degrees Celsius, which is very cold, often close to or below freezing. 3. What kind of weather do microtherms need besides temperature? Microtherms can handle some snow in the winter. In the warmer months, like spring and summer, they need enough rain to grow well. 4. Where are microtherms found? Microtherm plants are commonly found in places that are farther from the equator, where it's cooler. Examples include Canada, northern parts of Europe, Russia, and high mountain regions where it stays cool even in summer. 5. Examples of microtherm plants. Trees like pine, spruce, and fir are microtherms. These trees have needle-like leaves and stay green all year, even through winter. You can find them in boreal forests, cold forests, and steppes, large grassy areas. Hecistherms, plants that live in extremely cold places like the Arctic. 1. What are hecistotherms? Hecistotherm plants that can survive in very cold, harsh climates. They are tough plants that can live in the Arctic region where the weather is cold nearly all year. 2. What kind of temperatures do hecistotherms need? In the winter, it's extremely cold, often way below freezing. In the summer, it's still very cold, just above freezing at best. 3. What type of plants are hecistotherms? Hecistotherm plants are things like mosses and lichens. Mosses are small, soft plants that grow close to the ground. Lichens are unique plants that can grow on rocks and soil. They are tough and don't need much warmth or sunlight. 4. Where do hecistotherms grow? They grow in Arctic regions near the North Pole, where it's too cold for most other plants to survive. This area is called the polar zone or tundra. In these places, it's so cold that trees cannot grow at all. 5. Why are mosses and lichens special? They are very strong plants that don't need much soil to grow. They can handle the extreme cold and short growing season of the Arctic, where other plants can't survive. Koppen's work and why he updated it. Vladimir Koppen, a scientist, wanted to classify or organize different climate types to show how they affect plant life. His first version was made in 1900, but he wasn't completely satisfied with it. Over time, he revised and improved his classification to make it as accurate as possible. Koppen's classification is still used today to help us understand how different climates around the world affect plant life. Quick recap. Microtherms are plants like pine and spruce trees that live in cool regions with short summers and long, cold winters. Hecistotherms are plants like mosses and lichens that can survive in extremely cold Arctic areas where trees cannot grow. Worked hard to improve his system to help people understand the relationship between climate and plant types worldwide. Hope this breakdown makes it clear and easy to understand. All right, let's go through Koppen's climate classification in a very simple way, explaining each part slowly so it's easy to understand. What is Koppen's climate classification? 1. Purpose. Vladimir Koppen created a system to help us understand and organize the different types of climates around the world. This system is based mostly on temperature, how hot or cold it is, and precipitation, how much rain or snow falls. 2. Why temperature and precipitation? Different types of plants and animals live in different climates. Temperature and precipitation are the main things that decide which plants can grow in each place. Koppen thought plants were a great indicator of climate. If we know which plants grow in an area, we can understand the climate. 3. Koppen's changes over time. He first introduced his classification in 1900. First revision, Koppen made his system more detailed by paying closer attention to monthly and yearly averages of temperature and rainfall. Further revisions, he continued updating his map until the 1930s, with additional versions published in 1936, Köppen-Geiger map, and 1953, Köppen-Geiger pole. Koppen's 5 main climate types categories. Koppen's system has 5 main climate types, each represented by a letter, A, B, C, D, and E. 1. Type A. A. Humid tropical climates. Description: hot and wet all year round. Temperature: Every month is warm, with an average temperature above 18 degrees 64.4 degrees. Precipitation, there's plenty of rain throughout the year. Example, Amazon rainforest and Southeast Asia are in this type. 2. Type B, dry climates. Description. These areas don't get enough rain, so they are very dry. In fact, evaporation, water turning into vapor, is greater than precipitation, rain. Types of dry climates. Desert, extremely dry with very little rain. Steppe, semi-dry with a bit more rain than a desert, but still dry. Example, Sahara Desert in Africa and the Gobi Desert in Asia. Extra note, type B is different from the other types because it's based on lack of rainfall, not just temperature. 3. Type C, humid mesothermal climates, warm, temperate, rainy climates. Description, these areas have mild winters and warm summers. Temperature, coldest month between 3 degrees Celsius and 18 degrees Celsius, 26.6 degrees to 64.4 degrees Celsius. Warmest month, above 10 degrees 50 degrees. Seasons, both winter and summer seasons are present. Example, Mediterranean regions like parts of California, Southern Europe, Italy, Spain, and Japan. 4. Type D, humid microthermal climates, cold snow forest climates. Description, these areas have cold, snowy winters. Temperature, coldest month below 3 degrees 26.6 degrees, which is very cold. Warmest month above 10 Celsius, 50 degrees Fahrenheit. Example, places with boreal forests such as Canada, Russia, and parts of Scandinavia. 5. Type E, polar climates. Description, cold all year round with no real summer. Temperature, the warmest month has an average temperature below 10 degrees 50 degrees. Example, Arctic and Antarctic regions like Greenland and Antarctica. How do these types differ? Types A, C, D, and E are all based on temperature. Type B is different because it's based on lack of rainfall rather than temperature alone. Why is Köppen system useful? Understanding ecosystems. It helps scientists and farmers know which plants and animals can live in each climate. Predicting plant growth. Farmers can predict which crops will grow best in each climate. Studying weather patterns. This system helps us see how climate affects life on Earth, including human settlements and natural habitats. Summary of Köppen's climate types. Type A, humid tropical, hot and rainy all year. Type B, dry, very little rain, leading to deserts and dry regions. Type C, humid mesothermal, mild winters and warm summers like the Mediterranean. Type D, humid microthermal, cold, snowy winters and short, cool summers like boreal forest regions. Type E, polar, cold year-round with no true summer like the Arctic regions. Köppen system is widely used because it's clear and organizes climates based on the two key factors, temperature and precipitation. Let's take a detailed step-by-step approach to understanding the Köppen climate classification system. This system helps categorize climates based on two main factors, temperature, how warm or cold it is, and precipitation, how much it rains or snows. It's like sorting climates into different types based on how hot or cold, wet or dry they are throughout the year. Step 1. Main climate types, the first letters. Köppen created 5 main types of climate. Each type is represented by a capital letter. 1A, tropical, hot and humid all year. 2, dry, very little rain. 3C, temperate, mild or medium temperatures. 4D, continental, cold winters, warm summers. 5E, polar, very cold, mostly freezing. Let's dive into each main type and see what they mean. A, tropical climates. These are hot climates that stay warm all year, with the coldest month averaging 80 degrees or higher. A lot of rain falls, sometimes every month. Example, the Amazon rainforest in South America. B, dry climates. These places get very little rain. The air is often dry and water quickly evaporates. Dry climates are divided into deserts and steppes, semi-dry grasslands. Example, the Sahara Desert in Africa is an extreme dry climate. C, temperate climates. Mild temperatures with cool winters and warm summers. They have enough rain throughout the year or a specific rainy season. Example, Mediterranean regions like southern Spain have mild, rainy winters and dry, hot summers. D, continental climates. Cold winters and warm to hot summers. often found in areas far from oceans like central Russia. Example, the Midwest in the United States has hot summers and cold winters with snow. Polar climates, freezing cold most of the year. Some parts are covered in ice all year. Example, Antarctica is a polar climate, very cold with ice all around. Step 2, extra letters for more details, the second letter. Now within each main type, we use a second letter to show more detail, especially about rain patterns. For A, tropical climates, F, rain all year, no dry season. M equals monsoon or short dry season equals winter dry season, less rain in winter. For B, dry climates equals steppe, semi-dry with grasslands. W equals desert, very dry with little to no rain. For C and D, temperate and continental climates equals summer dry season. W equals winter dry season, no dry season. For EE, polar climate tundra, cold but with a short period for some plant growth, or F equals ice cap, always frozen, no plant growth. Step 3, more details on temperature, the third letter. The third letter gives even more specific information about temperature. For B, dry climates, H equals hot, average yearly temperature 18 degrees Celsius or more. K equals cold, average yearly temperature below 18 degrees Celsius. For C and D, temperate and continental climates, A equals hot summers, warmest month of 2022 seas. B equals mild summers, warmest month below 22 degrees Celsius, with at least 4 months over 10 degrees Celsius equals cool summers, 1 to 3 months over 10 degrees Celsius. D's very cold winters, coldest month below -3 degrees. Polar climates, T equals tundra, warmest month between 0 degrees Celsius and 10 degrees Celsius. Ice cap, warmest month below 0 degrees Celsius. Putting it all together, examples. Let's go through a few examples to see how these letters work together to describe climates. Example 1, AF, tropical rainforest climate, equals tropical, hot all year. F equals rain all year, no dry season. Example location, the Amazon rainforest in South America. Example 2, R, tropical savanna climate equals dry winter season. Example location, African savannas in Kenya with hot, rainy summers and drier winters. Example 3, BS, steppe climate, B equals dry, little rain equals steppe, semi-dry. Example location, Central Asia's grasslands, which get some rain but are mostly dry. Example 4, humid continental climate, D equals continental, cold winters, warm summers. F equals rain all year, no dry season. A equals hot summer, warmest month over 22 degrees Celsius case in the Midwest in the USA, with hot summers and snowy winters. Special formulas for dry climates, B climates. In dry climates, there's a special formula to check if the climate is dry enough to be considered a desert or steppe. This formula is based on R equals annual rainfall in centimeters. T equals average annual temperature in degrees Celsius. For a place to be considered dry, rainfall should be below the following levels. RT28 if most rain falls in the warmest 6 months, if most rain falls in the coolest 6 months. T if rain is balanced all year. Example, if a location has an average temperature of 20 degrees Celsius, it should get less than 20 plus 28 equals 428 centimeters of rain per year to be considered dry. Recap of the Köppen climate classification system. 1. 5 main types, A tropical, B dry, C temperate, D continental, E polar. 2. Extra letters for rain patterns, show if there's a dry season, how much it rains, etc. 3. Extra letters for temperature, detail on how hot or cold summers and winters are. 4. Special formulas for dry climates to determine if a climate is dry enough to be called a desert or steppe. The Köppen climate classification system helps us understand different types of climates using just a few simple letters and rules. All right, let's dive deep into why Köppen's climate classification is so useful and effective, explaining each point in the simplest way possible. This system organizes climate by using temperature, how hot or cold it is, and precipitation, how much it rains or snows. These two factors are key to understanding the environment, and Köppen's system connects them to visible features like plants and vegetation in different areas. Temperature and precipitation are easy to measure. Temperature and precipitation are easy to measure with thermometers for heat and rain gauges for rainfall. Because they're easy to measure, scientists all over the world have collected tons of data on them. This is why Köppen chose these two elements. They are reliable, and we can use the data to compare climates everywhere. Example, we know it's hot and wet in the Amazon rainforest because we can measure high temperatures and lots of rain there. 2. Defines climate regions precisely. By using statistics, data from temperature and precipitation, Köppen's system gives clear boundaries for different climate types. These statistics make it easy to tell where one climate type ends and another begins. Example, in Köppen's system, there's a clear line marking where the tropical rainforest climate ends and a savanna climate begins. 3. Temperature and precipitation show climate's real impact. Temperature and precipitation reveal how climate controls the environment more clearly than other factors. These two elements directly affect plants, animals, and human activities, more than things like air pressure or wind. Example, deserts have very little rainfall, so only certain types of plants like cacti can survive there. 4. Visible connection between climate and vegetation. Köppen's system links climate directly to vegetation, types of plants. You can see the effect of climate on the environment because different plants grow in different climates. Example, in tropical climates with lots of rain, like in the Amazon, we see dense forests. In dry desert climates, we see sparse vegetation like shrubs and cacti. 5. Real-world impact. It's not just theory. Köppen's system isn't just abstract or theoretical. It's based on what we see in nature. He linked climate to actual vegetation patterns, so it's practical and useful. Example, in cold climates with snow and ice like in the Arctic, we see no trees, only small plants that can survive the harsh weather. 6. Effective precipitation concept. Köppen introduced effective precipitation, which means he looked at how rain actually impacts plants. Effective precipitation depends on potential evapotranspiration, how much water plants lose through heat. Example, in a cool, temperate forest with moderate rainfall, trees grow well because the rain is enough for their needs. But in a hot desert, even with the same amount of rain, the water dries up fast, so fewer plants can grow. 7. Relationship between heat and moisture is recognized. Köppen's system acknowledges how heat and moisture interact. Evapotranspiration, water loss from plants and soil due to heat, controls how much moisture plants need. Example, in warm areas like tropical rainforests, there's a lot of rain and moisture. But in hot deserts, high temperatures dry out the land quickly, making it difficult for most plants to survive. 8. Climatic boundaries are vegetation lines. Köppen designed his system that climatic boundaries, lines between different climates, align with vegetation boundaries. This means that these boundaries mark where certain types of plants can or cannot grow. Example, the 10 degrees Celsius isotherm, a line for areas where the warmest month is 10 degrees Celsius, marks the edge of the tundra region. This line is also the northern limit where trees can grow. Beyond it, it's too cold for trees. Why this system is so appealing for geographers. Geographers, people who study Earth's features, love this system because it links climate to what we can see in the natural world. Seeing how climate affects vegetation helps geographers understand ecosystems, weather patterns, and land use. Summary, Köppen's system is simple yet powerful. By focusing on temperature and precipitation, it uses data that's easy to collect worldwide, provides clear, precise climate boundaries, links directly to visible features like plants and trees, recognizes the balance between heat and moisture. This makes it a valuable tool for understanding Earth's climates and how they shape our environment. Let's break down the advantages of Köppen's climate classification in the simplest way possible. We'll explore why it's useful, how it works, and why it's popular with geographers and students. I'll explain each point step by step. Advantage 1, easy to use with simple data. 1. Köppen's classification only needs two main things: Temperature, how hot or cold a place is. Precipitation, how much it rains or snows in a place. 2, why this is useful. These two things, temperature and precipitation, are easy to measure. Almost every place on Earth has this data because it's basic information collected by weather stations. 3, how it works. With just these two pieces of information, you can figure out the climate type of a place. For example, if you know it's hot and rains a lot all year round, that area might be classified as a tropical climate. Example, let's say you want to know the climate of a place in South America. You find out the average temperature and rainfall. Based on that data, you can assign it a Köppen climate type without needing complex tools. Advantage 2, descriptive and generalized, great for geographers. 1, what does descriptive and generalized mean? Descriptive means it gives clear information about the climate. Generalized means it groups similar climates together, so it's easier to understand large patterns. 2, why geographers like it? It helps them study broad climate patterns around the world. Instead of focusing on tiny details, they can see the big picture of how climates are spread out globally. Example, imagine you're looking at a world map. Köppen's classification shows large areas with similar climates like deserts or tropical rainforests, making it easier to compare different regions. Advantage 3, shorthand code with letters saves time. 1, Köppen used a letter system for different climates. For example, A for tropical, B for dry, C for mild, and so on. 2, why is this useful? Instead of writing long descriptions like hot and rainy all year, Köppen just uses a few letters to represent each climate type. This saves time and keeps it simple. 3, how the letter system works. Each main climate type has a letter, and subtypes like dry summers or cold winters get extra letters. For example, AF means tropical rainforest, hot and rainy year round, while Biederak means hot desert. Example, let's say you're a geographer describing different climates in a report. Instead of saying hot desert with very little rain, you can just use it's a quick, clear way to communicate climate types. Advantage 4, easy for all learning levels. 1, Köppen's system is simple and detailed. It's detailed enough to cover all the different climates, but it's also simple enough for students and teachers at all levels to understand. 2, how this helps in education. Students can quickly learn and remember the climate types using the letter system. Teachers can easily explain it using the map, letters, and general climate groups. 3, why it's popular in schools. It's a clear and straightforward way to teach climates. Students don't get overwhelmed with too many details. Instead, they get a good understanding of how climates differ around the world. Example, a teacher can use Köppen's system in a classroom to show students where deserts, rainforests, and snowy regions are on a map. The students can learn to identify each climate type just by looking at the letters. Summary of advantages. 1, easy data requirements. Just temperature and precipitation are enough to identify climate types. 2, big picture view. It's descriptive and groups similar climates together, making it ideal for geographers. 3, shorthand code with letters. Köppen's letter system saves time and makes it easy to communicate climate types. 4, great for all levels. Simple and detailed enough to be used in education at all levels. Final thought. Köppen's system is unique because it doesn't require a lot of complicated data. It's practical, helps people see global patterns, and is simple enough for everyone to understand. This is why it's one of the most widely used climate classification systems in the world, perfect for both scientists and students. Let's dive into the limitations of Köppen's climate classification system in a way that's simple and easy to understand. I'll explain each drawback step by step, using examples so it all makes sense. Limitation 1. Limited data used, temperature and precipitation only. 1. Köppen's system uses just two pieces of data. Temperature, how hot or cold a place is. Precipitation, how much it rains or snows in a place. 2. Why this can be a problem. Köppen left out other important weather factors like wind, how strong or weak it is, Cloudiness, how often the sky is cloudy. Daily temperature extremes, how hot or cold it gets in a single day. 3. Example. Imagine two places with similar temperatures and rainfall, but one is windy and cloudy, while the other is sunny with calm weather. Köppen's classification would group them the same way, even though they feel very different. Limitation 2. Inaccurate precipitation estimates. 1. Köppen only uses average monthly precipitation. He looked at the total amount of rain or snow in a month, not how intense, strong, or frequent how often the rain or snow was. 2. Why this is a drawback. Precipitation can vary a lot, even within the same month. Two places might get the same amount of rain, but one might have heavy rains a few days a month, while the other has light rain almost every day. 3. Example, place A and place B both get 100 millimeters of rain in July, but place A has heavy rain in 2 days, while place B has light rain every day. This difference affects the way people live, yet Köppen's system treats them the same. Limitation 3 doesn't explain why climates happen. 1. Köppen's system is based on observation, what we see, rather than causation, why it happens. He looked at temperature and precipitation data without explaining the causes of these climates. 2. Why this is a limitation. Modern climatology, the study of climate, studies air masses, large areas of air with similar temperature and moisture, which help explain why certain areas have certain climates. Köppen's system doesn't include air masses, so it doesn't tell us why a place has a specific climate. 3. Example. Today, scientists know that air masses from the ocean bring moist air to coastal areas, while dry air masses from deserts bring less moisture. Köppen's classification doesn't include these air mass factors, so it misses out on these explanations. Limitation 4. Symbols can be hard to understand. 1. Köppen's letter system can be confusing at first. Köppen used letters like A, B, C, D, E and additional symbols to describe climate types. While these letters are a shortcut, they can be tricky to understand without practice. 2. Why this can be a problem. The system might seem hard to understand for beginners because it doesn't describe the climate in words, just letters. For example, CFB might be confusing at first glance as it doesn't explain clearly what kind of climate it is without a key or a legend. 3. Example. CFB stands for a mild, humid climate with no dry season and warm summers. Until you learn what each letter means, it's hard to know this by just looking at the code. Summary of Köppen's limitations. 1. Limited data, uses only temperature and precipitation, leaving out wind, clouds, and temperature extremes. 2. Precipitation estimates, doesn't show how intense or frequent rainfall is, only monthly totals. 3. No explanation for causes, does not include factors like air masses, so it doesn't explain why climates exist. Number 4. Complex symbols. Letter codes can be confusing at first because they don't describe climates in words. Final thought. Köppen's system was a groundbreaking way to classify climate, and it's still useful today for understanding general climate types. However, these limitations remind us that it's not perfect and can't explain everything about a place's climate. Modern systems now try to include more details, like air masses and precipitation types, to give a fuller picture. Sure, let's break down Thornthwaite's climate classification in even simpler steps with more details to make it very clear. 1. Who was Thornthwaite? C.W. Thornthwaite was a scientist who studied climates, a climatologist from America. He wanted to find a way to describe and group different climates in the world, especially how these climates help plants grow. 2. Thornthwaite's 1931 climate classification. In 1931, he created a system to classify climates. This system was more detailed than earlier ones, like Köppen's, and it focused specifically on 2 things. 1. How helpful rainfall is for plants, called precipitation effectiveness. 2. How useful the temperature is for plants, called thermal efficiency. 3. Main parts of Thornthwaite's classification. Part A, precipitation effectiveness, how useful rainfall is. What is precipitation? Precipitation is any form of water that falls from the sky, like rain or snow. What is precipitation effectiveness? Thornthwaite didn't just look at how much rain an area gets. He thought about how well that rain helps plants grow. Why? Even if an area gets a lot of rain, it may not all be helpful. For example, if it's very hot, much of the water may evaporate quickly, turns to vapor and goes into the air before plants can use it. How to measure it? PE ratio? Thornthwaite created a formula to measure how effective the rainfall is. This is called the PE ratio. P stands for precipitation rain and E stands for evaporation. To find the PE ratio, he divided the monthly precipitation rain by the monthly evaporation. Example, imagine you have 5 inches of rain in a month, but 3 inches evaporate quickly because it's hot. So a PE ratio of 5 inches rain, 1 of 3 inches evaporation equals 1.67. A higher PE ratio means more water is available for plants. Thermal efficiency, how useful temperature is. What is thermal efficiency? This is about how helpful the temperature is for plants. In general, plants need a certain amount of warmth to grow, but if it's too hot, they might struggle because the soil dries out faster. 4. How Thornthwaite divided climates using the PE ratio and the temperature. Thornthwaite divided climates into 5 humidity groups. These groups help us understand how dry or wet an area is and how good it is for plants. The 5 humidity groups. 1. Very humid, lots of water available, so plants grow very well. 2. Humid, enough water for plants to grow easily. 3. Subhumid, somewhat limited water, plants may grow, but it's harder. 4. Semi-arid, low water availability, plants struggle to survive. 5. Arid, very little water, plant growth is very difficult. Example of these groups in real life. Rainforest, very humid, constant rain and warmth, so plants grow easily and quickly. Grassland, humid or subhumid, enough rain but not as much as a rainforest. Plants grow but might dry out in certain seasons. Desert, arid, very little rain, so plants like cacti that need little water can survive, but most plants can't grow there. 5. Why Thornthwaite's classification was useful, more detailed than just rainfall amounts. Thornthwaite's system isn't just about how much it rains, but also considers how much water plants can actually use. Combines temperature and rainfall. This classification considers both temperature and rainfall, giving a clearer picture of how climates affect plant growth. Good for understanding plant growth. His system is especially useful for studying vegetation, as it shows where plants can grow easily and where it's hard for them. 6. Summary. Thornthwaite's classification is a way to understand climates based on rainfall effectiveness, PE ratio, and temperature. He divided climates into 5 groups, from very humid, easy for plants to grow, to arid, very hard for plants to grow. By using both rain and temperature data, his system helps us understand which climates are good for plant growth and which are not, by considering not only how much it rains, but also how helpful that rain is, plus how temperature affects this. Thornthwaite's classification gives a more accurate look at how climate supports life.